Pick up a magnet and stick it to your fridge. Simple, right? Now press your hand against the fridge. Nothing. It just slides off. But here's the thing that should blow your mind. Every single atom in your hand is already a tiny magnet. So is every atom in your arm, your face, your entire body. You are made of trillions of microscopic magnets right now. So why don't you stick to the fridge? That's what we're figuring out today. To understand magnets, you have to zoom way, way in, past the metal, past the molecules, all the way down to electrons. Every electron in the universe does something incredible. It spins. And when a charged particle spins, it creates a magnetic field. Think of each electron as a microscopic bar magnet with its own north and south pole. This isn't a metaphor. Each electron genuinely produces a real magnetic field just by existing and spinning. But here's the catch. In most atoms, electrons come in pairs, and these pairs spin in opposite directions. One spins up, the other spins down. Their magnetic fields point in opposite directions and cancel each other out perfectly. It's like two equally strong people playing tug of war. Nobody moves. The atom ends up with zero net magnetism. And that's why most stuff in the universe, wood, plastic, water, your skin, isn't magnetic. The electron magnets are there, but they're canceling each other out. But a few elements broke the rules. Iron, nickel, cobalt, and gadolinium have electrons that refuse to pair up. These rebel electrons keep spinning the same direction with nobody to cancel them out. Each atom of iron has 4 unpaired electrons, each one generating its own magnetic field. So, every single iron atom is a genuine little magnet. That's only 4 elements out of 118 on the entire periodic table. Just 4 that have this special arrangement. So if every iron atom is a magnet, then a nail should be a magnet too, right? Grab a regular iron nail from your toolbox and hold it near some paper clips. Nothing happens. No attraction, no sticking, nothing. But every atom in that nail genuinely is a tiny magnet. So what's going on? The problem is direction. Those trillions of atomic magnets inside the nail are pointing every which way. North, south, left, right, up, down. They cancel each other out, just like the electron pairs did. But iron does something clever that most materials don't. Iron atoms naturally organize themselves into neighborhoods called magnetic domains. Inside each domain, billions of atoms line up and point the same direction. They're like little teams. But here's the key. Each domain points a different way from its neighbors. One domain points north, the next points east, another points south. From the outside, they all cancel out. The nail has millions of tiny magnets inside it, organized into teams that all disagree with each other. So how do you turn a nail into a magnet? You force those domains to agree. Take a strong magnet and stroke it along the nail in the same direction over and over. What you're doing is bullying the domains into alignment. The domain walls shift. Smaller domains get swallowed by larger ones. One by one, the neighborhoods surrender and point the same way, and suddenly, your nail picks up paper clips. You didn't add anything to it. You just convinced trillions of atoms to cooperate. But here's the fragile truth about magnets. Drop one on the floor hard enough, and it gets weaker. The impact shakes the atoms and knocks some domains out of alignment. Hit it with a hammer, and you can destroy its magnetism entirely. Heat it up, and the same thing happens, but even more dramatically. The thermal energy makes atoms vibrate so wildly that the domains can't hold together. The hotter it gets, the more domains fall apart, until the magnetism just vanishes. Every magnetic material has a breaking point called the Curie temperature, named after Pierre Curie, who figured this out back in 1895. For iron, it's 770 degrees Celsius. Heat iron past that temperature, and its magnetism completely dies. The atoms are still tiny magnets, but the heat is shaking them so violently that no domain can stay organized. It's like trying to get a stadium full of people to do the wave during an earthquake. The cooperation just isn't possible. Now zoom out, way out. The biggest magnet you interact with every single day is the Earth itself. Deep inside our planet, liquid iron churns and flows in the outer core. That moving liquid metal creates electrical currents, and those currents generate a massive magnetic field that wraps around the entire planet. This magnetic field stretches thousands of kilometers into space, forming an invisible shield that deflects charged particles blasting toward us from the sun. Without it, solar wind would have stripped away our atmosphere billions of years ago. And that's exactly what a compass does. The little needle inside a compass is a tiny magnet with its domains carefully aligned. It swings to point north because it's responding to Earth's magnetic field, a magnetic conversation between a tiny piece of metal in your hand and a churning ocean of liquid iron 4,000 kilometers beneath your feet. Magnetism connects the smallest things in the universe, spinning electrons to the largest, entire planets. It works across every scale imaginable. So next time you stick a magnet to your fridge, think about what's really happening. Trillions of atoms inside that magnet all decided to point the same way. Their electrons spin, their fields align, their domains cooperate, and together they hold on. Your hand is full of the exact same kind of tiny magnets. Every atom in you is a magnet. The only difference between you and a fridge magnet is that your atoms could never agree on which way to point. If you like this video, check out one of these, and don't forget to subscribe.